Hello and welcome to the Math Studio. In this video, we're going to look at graphing reflections in the y-axis. Now, in the recent video that I've uploaded, we looked at reflections in the x-axis. That's where we put the negative sign in front of the f. This time around, we're going to reflect now in the y-axis. So it's kind of reflecting it horizontally, in fact. So from this way sort of to this way, or vice versa, in fact. So the first point, let's have a look at it. Given y equals function x, then y equals f of negative x. Now notice now where the negative is, instead of being in front of the f, it's now in front of the x itself, reflects the original graph in the y-axis. So what that means is, practically, is that all positive x values become negative and vice versa. So whatever's positive becomes negative, whatever's negative then becomes positive. So effectively, whatever's in quadrants 1 and 4 get flipped to quadrants 2 and 3, and whatever's in quadrants 2 and 3 get reflected back to quadrants 1 and 4. Let's have a look at an example. So let f of x equal x squared minus 3x plus 1. So that's again just a parabola, but it's an off-center parabola. So its axis of symmetry is no longer the y-axis. So we can see what the reflection is going to look like. Then its reflection in the y-axis is given by the equation f of negative x, okay, is equal to negative x squared minus 3 outside of negative x plus 1. So what that means is that if we go back to the original function, okay, so wherever you see an x, we're going to replace it with negative x. That's sort of as simple as that, really. And that's it. Okay, so if we then sort of expand the brackets, so negative x all squared, sort of all negatives become positives, and 0 stays as 0, of course. Plus 3x, so negative 3 times negative x gives you positive 3x, plus 1. So let's have a look at these two graphs graphed on the same set of axes, and I'm going to graph it using just my graphing calculator there. So I've entered in the original function. So what I'm going to do now is type in the reflected function, or what it's going to look like. So I'm actually going to type it in just before I actually expand it. So imagine the x, we replace it with negative x. So, and let's just see what it looks like. So negative x all squared minus 3 outside of negative x, so negative x plus 1. Okay, and let's see what happens when we draw them. And there you go. So the blue parabola there is our original parabola, and the red parabola there is our reflected parabola. So if I sort of scroll around, and okay, you can see clearly the horizontal reflection. So it's a reflection in the y-axis there. So notice that anything on the y-axis itself, well, obviously 0, if the x value is 0, then reflecting 0 just sort of stays as its own point. But any other point, for example, so this point here, that's sort of around positive, just after positive 2.5 or 2.5. Its reflection is basically the same sort of distance away from 0, but it's around negative 2.6 thereabouts. Thank you for watching.